In this question, there is a submarine which is located at these given coordinates relative to a ship positioned at the origin. And the directions are mentioned vis-a-vis the axis. X is due east, Y is north, Z is vertically upwards. All distances are in kilometers, and the direction vector of the submarine is given. We have to find the equation for the line along which it travels. So for the equation of the line, let's write down the basic equation. The general equation for a line in vector form is r is equal to a plus lambda b, where r stands for the position vector of any random point lying on the line. A stands for the position vector of the initial position. So in this case, that will be 0.8, 1.3 minus 0.3. Lambda is a variable parameter. B is the direction vector, which in the question they have given as -2, -3, and 1. So let's put all the values in. We'll get r vector equals to, so for A, it's the position vector of the initial position. Let's write that in the column form, 0.8, 1.3 minus 0.3 plus lambda times the direction vector is -2, -3, and 1. So that's the answer for part A. Moving ahead to part B, the submarine reaches the surface of the sea at point P and we are supposed to find the coordinates. The submarine reaching the surface of the sea implies that one of the coordinates has to be 0. Which coordinate will that be? So we look at the directions. X is east, Y is north, but the Z is vertically upwards. So the Z direction is basically the submarine going up and down. So when the submarine reaches the surface of the sea, it's the Z coordinate, the Z coordinate of the submarine, which is equal to 0. Let's use the vector equation of the line to get the Z coordinate. So let's say if we simplify this entire vector equation, the X coordinate will be 0.8 plus lambda into -2. Y is 1.3 plus lambda into -3. Similarly, the Z coordinate which we require is minus 0.3 plus lambda into 1. So I'll only write down the Z coordinate here. We'll write negative 0.3 plus lambda into 1. Since the Z coordinate is supposed to be 0, we put the Z coordinate as 0. So lambda comes out as 0.3. And now if we try to get the coordinates, X coordinate was 0.8 plus lambda into -2. So let's write that down. X will be 0.8 plus lambda into -2. So we will put lambda is 0.3 in this particular case. And solving this, we get 0.2 as the answer for the X coordinate. Y coordinate will be 1.3 plus lambda into -3. So let's write that down. 1.3 plus lambda into -3. If we put the value of lambda as 0.3, the Y coordinate comes out as 0.4. And the Z coordinate, of course, is 0. So the answer for the B1 part is 0.2, 0.4, 0. B2 part, find OP. OP is the length of the line segment OP, which in this case we will represent as the magnitude or the modulus of vector OP, because that's the definition of magnitude, the length of the line segment. OP vector, let's write down, will be written as 0.2i plus 0.4j plus 0k. And we use the formula square root x square plus y square plus z square. So the magnitude will become this. And if you solve this square root expression, we'll get 0.447 as the answer. And for the units, we go back to the question. All the distances are measured in kilometers. So the final answer is also in kilometer. It will be 0.447 kilometers, which can also be written as 447 meters. Question, we have to find the expression for position vector of the ship. So let us recall the basic expression. If an object has an initial position vector of A and moves with a constant velocity B, the position vector is given by this expression, A plus TB, where A stands for the initial position vector and B stands for the velocity vector. So in this question, the A vector, which is the initial position vector, is 1, 4. And you can see the diagram on the left where the harbor is at the origin and the ship is at 1, 4. So by definition, if I connect the harbor origin with the ship, this HS will be the position vector initially. That is A vector. So let's write down A vector can be written as 1i plus 4j, or in the column notation, we can write like 1, 4. The velocity vector they have given already. So the velocity vector is 1.2 minus zero point 0.6. This is the B which we require for this expression. Hence, putting both the values, we will write down the vector R as 1, 4, which is the initial position vector, plus t times the velocity vector, which is 1.2 minus zero point 0.6. And that's the answer for part A. Moving to part B. Find the time at which the bearing of the ship from the harbor is 45 degrees. So let us understand the concept of bearing when the angle is 45 degrees. So have a look. If the bearing is 45 degrees, that means the angle with the north is 45 degrees. Here, consider point B as the north. Whenever the angle is 45 degrees, so consider this right angle triangle, tan 45 will be opposite upon adjacent. So BC upon AB. Tan 45 is 1, and that's why we get BC and AB are equal. We say the x component of the displacement AC is equal to the y component of AC. In part B, we are given that the angle required is 45 degrees. So we have to use this concept, x component and y component are equal. In the part A, we had found out the vector equation. So individually, let us identify the x coordinate as well as the y coordinate. X coordinate will be 1 plus t into 1.2, and y coordinate will be 4 plus t into negative 0.6. So let's write that down. X will be 1 plus 1.2 into t, and the y component is 4 minus 0.6 t. If the angle is 45 degrees, which is in this particular case, so we will equate the x and y components. So let's do that. The x component, let's equate that with the y component. If we simplify this expression, we'll get 1.8 t equals to 3. This implies t will be 3 upon 1.8. Let's simplify this. So we'll get 10 upon 6 or 5 by 3. So 5 by 3 is the time after which the bearing of the ship is 45 degrees. Now, the question was to find the time at which the bearing of the ship is 45 degrees. We already have found the t, but initially observe in the question they have given, the starting point was 1 p.m. So we'll have to add the 5 by 3, which we have gotten, to 1 p.m. And let's do that. So the time, final time which we require is 1 p.m. plus the 5 by 3. Now, 5 by 3, if you simplify, is actually 1.66 hours. Let's convert that into minutes as well. So 1.66 we can write as 1 plus 0.66. So 1 hour and 0.66 hours. So let's convert 0.66 hours into minutes. So we multiply 0.66 only with 60. That will give us the answer in minutes, which comes out as 40. So 5 by 3 incidentally is 1 hour plus 40 minutes. Now we need to add this much time to the original time of 1 p.m. So 1 p.m. plus 1 hour is 2 p.m. and we add another 40 minutes to it. So the final time will be 2 p.m. 40 minutes, which is basically 2:40 p.m. And that's the answer for part B. In this question, a plane's velocity vector is given, and it's mentioned that the plane is flying into a wind, and the wind velocity is also given. V is perpendicular to W. So the plane velocity is perpendicular to the wind velocity, and then we are supposed to find the value of K. In the chapter of vectors, remember, whenever we see perpendicular, which means theta is 90 degree, we employ the concept of dot product or the scalar product. In the scalar product, which is also called the dot product, let's say A vector is Pi plus Qj plus Rk. This is the column notation. And let's say B vector is Lmn in the column notation. So the dot product is Pl plus Qm plus Rn. Now, if the angle is 90 degrees, then we use the basic formula of dot product. A dot B is mod A mod B cos theta. If theta is 90, cos 90 is 0.
And then we can say A dot B is equal to 0. That's why always remember, whenever two vectors are perpendicular, we take the dot product and put that equal to 0. Since in the question they have given V is perpendicular to W, that means V dot W will be equal to 0. Now V vector is -3, -12, and 4. You take the dot with the wind velocity, which is 4, k, and 2. And we will put that equal to 0. Now to find the dot product, all we need to do is just multiply the x components together. -3 into 4 will give us -12. Then multiplying the y components together, -12 into k will be -12k. And then multiplying the z components, 4 into 2 will get us 8. And then we add all these numbers. And this is the dot product, which is equal to 0. So let's simplify this. We get -12 -12k plus 8 equals to 0. Hence, we can write 12k is -4. This implies k is -4 upon 12, which is equal to -1 by 3. And that's the answer for this question.